Welcome to this video about the changes happening all around us. We will explore the fascinating world of physical and chemical changes. Observe the world around you. Ice melts into water, flowers bloom, fruits ripen, wood burns, even iron slowly rusts. Changes happen everywhere, every day. But have you ever wondered, are all these changes the same? Every day, we notice things changing around us. Ice melts, clothes dry, flowers bloom, and fruits ripen. To understand these changes, we act as observers, using our senses to note the physical and chemical transformations taking place. Look closely at each example. Has the shape changed? Has the size changed? Has the state changed? Don't worry about naming the change just yet. By documenting the before and after states of various objects, we can start to categorize these different types of changes. In all these examples, something has changed, but the material itself is still the same. Ice becomes water, paper changes shape, a balloon expands, and chalk breaks into powder. No new substance is formed. These are called physical changes, where only the appearance, shape, size, or state changes. Let's zoom in to see something our eyes cannot normally see. Inside ice, the water particles are packed closely together. When the ice melts, the same particles move more freely. When water becomes steam, those very same particles spread farther apart. The particles never change into something new. Only their arrangement and movement change. Now let's observe a different kind of change. When vinegar and baking soda are mixed, bubbles begin to form. The gas produced turns lime water milky. These are important clues that something completely new has formed. Whenever a new substance is produced, the change is called a chemical change. Let's zoom in again. During a chemical change, the atoms don't disappear. Instead, they rearrange. Old connections break and new ones form. These new combinations create substances with different properties. That's why chemical changes produce materials that are different from what we started with. Now let's compare the two types of changes. In a physical change, the substance stays the same. Only its shape, size, or state changes. In a chemical change, atoms rearrange to form new substances with new properties. Whenever you're unsure, ask yourself one important question. Has a new substance formed? Have you seen an old bicycle or an iron gate covered with a reddish-brown layer? That's rust. When iron reacts with oxygen and water in the air, it slowly changes into a new substance called rust. Because a new substance is formed, rusting is a chemical change. Combustion, or burning, is another chemical change. It releases heat and light as fuel reacts with oxygen to create new substances. When wood burns, it doesn't simply get hot. It changes into ash, carbon dioxide, and water vapor while giving off heat and light. This process is called combustion. A fire needs three things to keep burning: fuel, oxygen, and heat. Together, they form the fire triangle. If even one of these is removed, the fire goes out. That's why covering a flame with a glass or using a fire blanket can safely extinguish it by cutting off the oxygen supply. A burning candle is special because two different kinds of changes happen at the same time. The solid wax melts into liquid wax and then changes into vapor. These are physical changes because the wax remains the same substance. But when the wax vapor burns, it reacts with oxygen to form new substances while releasing heat and light. That part is a chemical change. Some changes can be undone. Ice melts into water, but it can freeze back into ice. Water becomes steam, but it can condense back into liquid water. A folded paper can be unfolded, and a balloon can be deflated. When the original form can be restored, we call it a reversible change. Some changes cannot be undone. Burnt paper cannot become paper again. A rusted nail cannot return to shiny iron on its own. A ripe banana cannot become unripe, and popcorn cannot change back into corn kernels. These are irreversible changes because the original form cannot be restored. Not every change is simply good or bad. Cooking food, making curd, and turning kitchen waste into compost are useful changes. Rusting, food spoilage, and forest fires can be harmful. Sometimes the same change can be useful in one situation and harmful in another. Scientists always consider the context before deciding. Rocks may seem strong and permanent, but nature changes them slowly. Sunlight, rain, wind, freezing water, and growing roots gradually crack and break rocks into smaller pieces. Water and air can also react with the rocks, changing their composition. Together, these slow physical and chemical changes are called weathering. After weathering breaks rocks into smaller pieces, another process begins. Wind, flowing water, and gravity carry these loose particles from one place to another. This movement is called erosion. Over time, these transported materials settle and help create new landforms and fertile soil. We've explored many kinds of changes around us. Some are physical, while others are chemical. Some can be reversed, while others cannot. Nature changes rocks through weathering and moves them through erosion. Whenever you observe a change, remember one simple question: has a new substance formed? That question helps us understand the world around us. Remember that every discovery begins with a careful observation of the world around us. Science begins with noticing. Every day, the world around you is changing in small and fascinating ways. Keep your eyes open, stay curious, and let every observation become the beginning of a new discovery.